Welcome to Quant Solutions, where we demystify quant finance. Today, we're embarking on a really fascinating deep dive. We're looking at a foundational work from way back in 1900.
That's right. Louis Bachelier's doctoral thesis, Théorie de la spéculation.
Exactly. And it's not just some dusty old paper, is it? It's seen as, well, basically the start of quantitative finance.
It really is. Decades before anyone even called it that.
So our mission today is to, pull out the key ideas, give you a shortcut to understanding maybe why markets move like they do and how we can even model all that uncertainty.
And it's quite amazing when you think about it. A French mathematician, 70 pages, analyzing the Paris Stock Exchange.
Just 70 pages. Wow.
Yeah, and the core ideas were largely ignored for a long, long time. Only much later did people like Samuelson and, the Black Scholes guys rediscover it.
Incredible. So let's get into that core idea then. He said stock prices move randomly, like a random walk.
Pretty much, yeah. He essentially invented that concept for finance.
In 1900, what made that so, well, radical? How did it challenge how people thought about markets then?
Well, back then, the thinking was more deterministic. Look at past prices, find a cycle, predict the future. Bachelier basically said, no, especially in the short term. Those movements are inherently unpredictable. He put the math behind why. It was a huge shift towards thinking probabilistically.
And he even touched on ideas similar to Brownian motion before Einstein.
That's the really stunning part. The maths he used to describe these small random price changes, it looked a lot like what Einstein later used for, particles moving randomly in a fluid.
Wow. Okay, so if markets are random, if prediction is out, what can we know? That brings us to his fair game idea, right?
Exactly. It flows from the randomness. If the market is efficient and prices reflect information quickly.
Then you can't expect to consistently win just by speculating.
Precisely. The expected gain, mathematically speaking, is zero. It's a fair game.
Yeah.
This was like the seed of the efficient market hypothesis that came decades later.
So for you, listening now, what does that mean practically?
It means trying to consistently outsmart the market, especially short term, is probably not the best strategy.
Right.
Focus instead on managing your risk, diversification. Things built on understanding the probabilities, the randomness Bachelier was talking about.
Okay, but he didn't stop there. He went even further, trying to value options. That seems like a massive jump.
It was a huge leap. Remember, an option's value depends on where the price might go in the future.
Okay.
Uncertainty squared, basically.
So how did he tackle that?
He derived formulas, actual mathematical formulas to price these options. And they look remarkably similar in structure to the Black Scholes model that won a Nobel Prize much, much later.
No way.
Yeah, it was revolutionary.
Yeah.
Showing you could use probability theory to put a price on these derivative instruments. He also used continuous time models.
Yeah.
Like prices evolving constantly, infinitesimally, not just jumping at fixed intervals. It made the maths work for derivatives. And crucially, he identified volatility. The amount prices wiggle around is a key input. He quantified it.
So he's bridging maths, physics concepts, economics, showing finance could be a quantitative science.
Absolutely. That interdisciplinary leap was fundamental.
But like any model, it can't be perfect, right? There must be limitations.
Oh, definitely.
Yeah.
And that's a huge lesson for anyone in quant finance or really anyone using models. They're approximations.
Okay.
Bachelier, for instance, assumed price changes followed a normal distribution, a bill curve.
Which isn't quite right, is it? We know markets have.
Exactly. Fat tails. Those extreme events, big crashes or spikes, happen much more often than a perfect normal distribution would predict.
Right, so that's a crucial
A
reminder.
reminder for humility, yeah.
Yeah.
Models are powerful tools, but you have to understand their assumptions and where they might break down. Always check against reality.
So let's wrap this up. For someone starting out or just trying to get a better handle on finance, what's the big takeaway from Bachelier over a century later?
I think it's that core insight. Randomness, probability. They aren't just noise. They are fundamental to how markets behave. Even with all our AI and complex algorithms today.
It really grounds things, doesn't it? Thinking probabilistically, not searching for certainty that isn't there.
It's humbling, yeah. How one thesis could just lay out so much so early.
So maybe the question for you, the listener, is, what assumptions about market predictability are you holding on to, especially now? Might be time to challenge them.